Hello and welcome to 6-2 Law of Cosines. First, I have written for you all the various forms of the laws of cosines. Sometimes you won't necessarily always see them this way, and you're thinking, my God, there's 6 of them, how am I supposed to remember that? But keep in mind, they follow the same pattern. So on the left, in the standard form, you have it if you're solving for a side. So on the first one, you're solving for side A, next one side B, next one side C. Keep in mind that all this is based upon the ABC triangle that we talked about in the first lesson. You must have those in their proper order, otherwise it screws up everything. On the right, you have the equation that is solved for solving for the angle. So the cosine of A, cosine of B, cosine of C. The only thing that's missing from that is that once you do what's on the right there, b squared plus c squared minus a squared over 2bc, you have to take the inverse cosine of it to find the angle. What that's giving you is it's telling you the cosine of the angle is this, but you still have to find what the angle is based on an inverse or anti-cosine, whichever term you prefer. You can pause the video and take a look at those if you wish. If not, let's go forward. So here I have a triangle that is a side-side-side relationship. Now, wherever possible, I would like to use the law of sines. It's easier, it's quicker. I'm not squaring anything, I'm just cross-multiplying and dividing, punch it into the calculator, and I'm done. But the problem is I have 3 sides here, but I have no angles. So in this case, I'm going to use a law of cosine to solve for an angle. So this one right here, I'm using law of cosines. Okay, law of cosines. So my formula said that the cosine of b is equal to a squared plus c squared minus b squared over 2ac. I make sure that I properly label my triangle, which it has been done in figure 6.11, and A is 8 feet, B is 19 feet, C is 14 feet. So I plug in here and I've got, all right, 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14, and all of that equals negative 0.45089. Just some simple math, plug it in the calculator. That, I recommend you just type it in the calculator. I'd do parentheses, 8 squared plus 14 squared minus 19 squared, close parentheses, divided by parentheses, 2 times 8 times 14, close parentheses, enter. Get that number, you're done. The next step, however, if you'll notice on the right, b is equal to the inverse cosine of that. So we have found what the cosine of the angle is equal to, but now in order to find what the angle is equal to, I must take the inverse cosine of it. When I take the inverse cosine of negative 0.45089, I get approximately 116.8. So angle B is approximately 116.8 degrees. Now that I have one angle, and I have all these wonderful sides, I'm done with law of cosines. Remember, I said a moment ago, if I can use something other than law of cosines, I'm going to use something simpler. So next I'm going to use the law of sines, which we learned about in the last lesson. Okay? It's not doing it a cheaper way, it's just working smarter. So I'm solving for the sine of A. So my equation would be sine of A over A equals sine of B over B. I have B, that's 116.8. I just solved for that. I have side B, which is 19 feet, and side A, which is 8. So I have 8 times the sine of 116.8 over 19, which gives me 0.37583. Now remember, that's the sine of the angle. In order to find the angle, I must take the inverse sine of it. When I do so, as you see on the right, I get 22.1. So now I've got angle A is 22.1, I've got angle B is 116.8. Now, if you were just wanting to punish yourself, you could use law of cosines. If you were wanting to punish yourself, you could use law of sines. But basic logic tells you don't work harder than you have to, stupid. So take your 2 angles, because you know the angles of a triangle add up to equal 180. 180 minus 116 minus 22.1 gives you 41.1, and that's your answer for angle C. So once again, I started with law of cosines. I just look at what do I need, what do I have. Now, could I have done another angle first? Could I have done the cosine of A equals B squared plus C squared minus A squared over 2 times B times C? Yeah, I could have. I could have done that. It doesn't matter which way you do them, but in this case, you start with the law of cosines, go to a law of sines, and finally just do some basic subtraction. Our second problem, here we have two sides and an included angle. The issue with this is, in order to use law of sines, I have to have an angle with a side across from it. Otherwise, it doesn't work. So what I do is I use to find A, because if I can find this little doohickey over here on the side, when I find A, I can use the law of sines for anything I want to. So to find A, the formula says A squared equals B squared plus C squared minus 2BC times the cosine of A. I have B and C. I've got the cosine. Let's go. 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25. How would I do that? I'd plug it into the calculator and let TI do the work for me. 9 squared plus 12 squared minus 2 times 9 times 12, cos 25, enter. A squared is equal to 29.2375. Now remember, A squared equals that. In order to find A, I take the square root of it to get 5.4072. So now I've got side A. Now I want to find, I've got 3 sides and an angle. I want to find my missing 2 angles. So I can easily do a law of sines here. The sine of B over B is equal to the sine of A over A. So the sine of B is, I'm finding that angle. The length of B is 9. Angle A is 25. And little a is 5.4072. So when I do all that, plug in the math, the sine of B is equal to 0.7034. So I go forward. The inverse sine of that is 44.7. So now I've got 3 angles, so I take 180 minus 25 minus 44.7, and it equals 110.3. And that is my answer. And that concludes our lecture.